Hi, Andy's here. Welcome. Today, let's talk about IBDP. Okay, it's called International Baccalaureate Diploma Program. Here we go. This is the one. Okay, International Baccalaureate Organization 2021. So this is actually the 2021 paper. Happened. I think the exam happening in May. Probably we can actually get down and we can check it. So it's probably there. It shows the time. Here we go. Yeah, Thursday, 6th May 2021 afternoon. So you have 1 hour and 30 minutes, 90 minutes to solve all the problems. And this is MAA, which means Mathematics Analysis and Approaches. Okay, this is a standard level. And this is paper 1. So normally you are not allowed to use, the rule is you're not allowed to use calculator, okay, in this paper. So as you can see here, the full mark is 80. Okay, I hope you can get 80, okay, for 2025 examination. Okay. So let's take a look at the last few problems. So there's section A, section B. So for section A, I think they are more fundamental, maybe a bit further. But for section B, they are a bit challenging, okay? So we can take a look at them. So normally you have a probability problem, a function-related problem, and another calculus-related problem. Normally, okay? You see the last one is a probability one, but this time we try this calculus one, okay? So let's work out this one together, okay? Well, we read this and we just solve one by one, okay? So first, we can show that the first derivative of this original function is this here. Apparently, you've learned how to differentiation, right? How to do the differentiation. If you've tried the fundamentals, the product rule, the quotient rule, the chain rule, and so on and so forth, right? The basic differentiation skills. So for this one, this is apparently, you see, y equals ln of x. So ln is the natural logarithmic function, right? Ln of x over x to the power of 4. So apparently we're going to use quotient rule, right? So let's give it a go. So the quotient rule tells us that when you have, let's put it here, okay? So when you have y, okay, I'm going to write it down. So when you have y equals maybe u of x, here, u of x over v of x. So when you differentiate with respect to x, right? So you can say dy over dx. And you will get v of x multiplied by u of x prime, okay? And then minus, here we go. I think you're going to get v of x prime and multiplied by u of x. And the whole thing over v of x squared, okay? So yeah, I have my formula here on my notes. You can always go and check the notes if you feel like, oh, I don't recall, I don't remember, it's not that clear. So just go check your notes and it works like that, okay? All right, so let's move on and try to show it works, okay? Let's change the color. So here we go. U of x is basically just ln of x, right? And v of x is just x to the power of 4. You can actually solve this step by step, but we can just quickly do this, okay? We can simply just write y prime. So we're gonna have here, v of x is just the x to the power of 4. We put it here, x to the power of 4. And this u prime of x, when you differentiate a logarithmic function, you basically just have 1 over there. That's x, right? So you're going to multiply by 1 over x, okay? And then minus, so what about v prime of x? So v of x is x to the power of 4. So differentiate x to the power of 4 with respect to x. So you're basically just going to get, I think it's going to be, so you're going to get 4 and then x cubed, right? And then you just multiply by ln of x again. So we put ln of x here. I use a little dot to show you there's multiplication sign over there, but normally you don't have to write down there. And then we are going to have v of x squared. So that's going to be x to the power of 8, right? So what you're going to do is you can do some canceling, yeah, because when you have the same factors on top and bottom, you can just get rid of them, right? So x to the power of 4 multiplied by 1 over x, you just get x to the power of 3, right? And then there's x to the power of 3, there's x to the power of 3. So you cancel this, you cancel that, and then here you only have x to the power of 5, right? So you will have this, so this equals, we have 1 minus 4 times ln of x, and then over x to the power of 5. That's it. It just worked, right? X to the power of 5. It's pretty easy as long as you remember all the rules and you also know how to do the implementation. Also, you don't make like minor mistakes, okay? Because I do have some students who tend to make some minor mistakes. You know, those missteps are not encouraged. Okay, so we get this, right? And then consider this function. We get f of x, pretty much the same. And its graph is there. The graph has a horizontal tangent at point P, right? So find the coordinates of P. So how can we do that? So in order to get the horizontal tangent at a point P, you basically just try to set the first derivative to be 0, right? Okay, so when you set it to be 0, the only possible way is going to be ln of x is going to be a quarter, because the denominator is not allowed to be 0, right? X is larger than 0. X is positive. Okay, so we know that ln of x, so let's put it here, okay? So we need to figure out, because it's a horizontal, right? Tangent at point P. So we need to figure out the x, the value on the x-axis, right? Simply, we let f prime of x is 0. So we have f prime of x is 0. And this just leaves us ln of x is going to be a quarter. So if this is a quarter, and then what about x? How are you going to handle this? So this is quite interesting, right? So you can actually try e to the power of something, and then you can actually figure out what's going on here, right? So you can say, you have this, right? That's a nice trick. You can say this is going to be e to the power of that. So equivalently, you're going to have e to the power of a quarter, okay? So apparently, this is just going to be, actually, we're going to put it here, okay? So when x is going to be e to the power of a quarter, and this is going to work, okay? So x is going to be e to the power of a quarter, okay? Because ln of e is going to be 1, okay? And also, when you have ln of e to the power of a quarter, okay? So you are going to have a quarter and multiply by, so this is some basic operations, some tricks from some operation, fundamental operation rules of logarithmic function, okay? So we basically just have a quarter and multiply by ln of e, right? So you already know ln of e is 1, so this is just a quarter, right? So it works. So x is going to be e to the power of a quarter, okay? So that's it. So when x is that value, you substitute this x in this original function, and then you are just going to get the y value, okay? And then we know the second derivative is here. You're going to show that P is a local maximum point. How you do that? So in order to show it's a maximum point, you need to make sure the second derivative is going to be a negative value, right? Okay, this is a little bit counterintuitive. So how can you show this is going to be a negative value? So basically, you can just use substitution, because you already know x is going to be e to the power of a quarter, okay? And then you can just use substitution and check this value. You notice that this value is going to be a negative value, and then it just works, right? Okay, so we try to solve this when the function is a positive value, and what will happen for x, right? So you basically just have ln of x over x to the power 4 is larger than 0. So you already know ln of x is going to be larger than 0. So x to the power 4 must be larger than 0, right? So in order to make sure x to the power 4 is larger than 0, I think this is quite straightforward, right? And for the final one, you try to sketch the graph of f showing clearly the value of the x-intercept and the approximate position of point P. So what is x-intercept? There's another similar term called y-intercept. It's like you have a line cutting through this x-axis, right? You have that intercept, right? So it means when y is 0, and what are the values for x? So you simply just have y is 0, so which means ln of x is going to be, ln of x over x to the power 4 is going to be 0. Is this going to be a positive one? Or do you think there's going to be negative value? Yeah, I'll leave this to you to think. And after after finishing watching this video, and I'll catch you for the next one. Bye.